The first thing we want to talk about is your power distribution, right? So we talked about power drops. Initially, when we talked about power drops, we have what you call an end-to-end transformation. So you will have, let me see, let me switch pens. So what you'll have is an end-to-end transformation. So here you have end-to-end, where V1 over N1 is equal to V2 over N2. Okay? So if I want to go from, let's say, 10,000 to, I don't know, 480. So if we were to look at how does this work? So if we say something like, how does this start? Well, it starts with the utility company. Then it goes to your distribution center. So we have a power distribution unit. And then we have our, what you call our residence or building, or you call it our target. So let's just call it target. So we have our utility, right? We have our PDU, stands for power distribution unit, and this can be any form of power distribution. It could be a generator inside a building or whatever. There's all sorts of power distribution units, and this is our kind of, let's call this our building, but let's call this our client, right? Whatever the client wants. Utility PD client. So our utility normally, and this is kind of a normal situation. Let's talk about a residential situation for a minute. In a residential situation, you'll have these transformer drops. So, or a building. Let's look at Nova's building. So you start, let's say something at, it can range from 10,000. Let's not do 10,000. 10 kVA to 35 kVA. It really is just a large number, right? And it drops to, let's say, 480. Okay, so you'll have a 10 to ratio of 10 kVA to 480 volt drop. And what is that? Well, that will be solved with V1 over N1, V2 over N2, right? So there's a ratio, a transformer ratio, where you would have N2 over N1 is equal to V2 over V1. And that ratio will determine your drop, right? So that's one. The second one is, let's just go from the client. So at Nova, use a lot of 208 and 120. So you'll have a Y transform, but let's say it goes to 208. Okay. So now this ratio is going from, 10 kVA, sorry, not kVA, 10 kilovolts, sorry, goes from 10 kilovolts to 480. Then from 480, it goes to 208. Okay. How does it do that? Well, it handles it this way. All right. So this is a kind of a drop. So in our normal scenario, you'll see something like this, and then we'll talk about the three-phase power here, the utility three-phase, and how the three-phase operates, how the single-phase operates in our next lecture. Okay. So these are our voltage drops. Okay. Now from the voltage drop, but when you deal with, let's say, a special scenario, so this is a kind of a normal, and we can call it 120 volt. This is kind of our normal system here. Okay. But let's just talk about, let's say, the data center. The data centers are slightly different. They use a little different tone. So what they start with is utility. All right. So you have utility, just like that. Okay. In our utility, it goes through a transformer, right? And of course the transformer, and of course you'll have the switchgear, right? So you have transformer, switch gears, all the stuff here. Then it goes to what you call a battery. Okay, and this is our battery, which is called our UPS, and this is really a battery. Okay, and UPS stands for uninterrupted power supply. Okay, so when we understand how this UPS is going to work, it'll definitely make our lives easier for everything else. Now, this is kind of off. So I'll probably have to write this a little cleaner. Okay. Um, and then we goes to what you call a PDU, right? A power distribution unit. So the difference between a standard where it goes from, let's say, a utility power distributed client, and the client needs an arrow, we go from utility, obviously you have a transformer, so here obviously you will have a transformer right in the middle somewhere, right? And the transformer is really that, okay? That's our transformer. So our transformer switchgear, UPS battery, and then we go to our PDU. So here is our PDU, okay? That's our power distribution unit. From the PDU, it goes to what you call a remote RPP, which is a remote power panel, okay? And then this from here goes to multiple clients, all right? So our multiple clients in our servers, our multiple clients here would be, in Nova would be different rooms, different buildings, and however you want to kind of look at it. Here, our multiple clients here are our racks. So you'll have, let's say, rack 1, rack 2, rack 3, and rack 4. So you have rack 1. Write it down. It's getting a little lost here. Rack 1, right? Rack 2, rack 3, and rack 4. All right, and so on and so forth. There can be multiple racks, right? So these are the layers you go through. And obviously, I want to put a box around our PDU. So our focus is really going to be, in our, when we talk about double conversion, we're really going to stick with this area in a little bit. So understand how the power drops are working. So our utility is roughly 34.5 kV. Okay, it goes through a transformation, which is V1 over N1, which is equal to V2 over N2. We covered that previously. Our UPS, that transformation resulting from here to here, is 480 volts. Okay? Now, this 480 to this 480 is going to be the same. The 480 will drop to 208 volts here. Now, obviously, this V1N1 V1 over N1 equals V2 over N2 is the same as V1 over N1 V2 over N2 here. So it's the same concept. Okay? So again, you apply the transformer here. Now, this is actually a little special because we're going to cover this in great detail in the next video. So the detail that you have to know that this is AC voltage. Okay? When it comes in the power supply, it is AC voltage. Okay? Then it gets these power battery, once any battery will become now DC voltage. So it leaves here, it goes through a process, right? And then it becomes AC voltage again. And then it goes to the PDU, and then it goes to the racks, okay? So your conversion is AC to DC back to AC, okay? And we will cover that in the next two videos on highly detail on why the mechanism in which these transformations happen, and then obviously we'll cover the full bridge rectifier in the next two videos.